Hi, I'm Malik Tenzi, and this is my honors pre-calculus graphing project. When doing this, I actually had a hard time thinking of a topic that would actually be interesting. So I thought back to stuff we learned in class, and I decided to do my project on tides of places like Bay of Fundy and the Bristol Channel. Most of the information given on the project is pretty accurate, but some of the stuff isn't. That's because I had to change some of the information or some of the stuff that I put into my equation to fit all the requirements of the project. So most of the amplitudes are correct, but some of the periods aren't. This is my first graph. This is a graph of the tidal range of the British Channel. The amplitude is 6.5. That's because it has a range of 13 meters from low tide and high tide. So I just divided 13 by 2 to get 6.5. The equation is y equals negative 6.5 sine parentheses pi divided by 9.3x plus 4.65. Here is a close-up of the equation for the graph I just showed you. As you can see right here, it is pi over 9.3, but that's not actually accurate. Usually it would be pi over 6.2, but it wouldn't be good for my project to use the same thing all over again, so I switched it up. Feel free to pause at any point in the video. This is my second graph. It is a graph of the highest tidal range that the Bay of Fundy has ever had. This happened many years ago, around 1966 or 1866. The equation for this is y equals 10.8 cosine pi over 6.2x. Here's a close-up of the equation. All the information on this equation is pretty accurate. I didn't really edit anything. This is my third graph, which is actually a combination of the average tidal ranges of the Bristol Channel and the Bay of Fundy. Here is a close-up of the equation for the graph. I did not change any information in this equation. Here's the fourth graph of my project. This graph has actually nothing to do with the Bay of Fundy or the Bristol Channel. Here's the close-up on the equation. Here is my final graph, which is a combination of all the other graphs put together into one graph. Sounds kind of confusing. And here is the final equation of the final graph. That's it. Thanks for watching. All the table values will be emailed to you along with the video. Thank you.